Hello everyone, this is the fifth lecture on conic sections. So, we will talk about parabola, ellipse and hyperbola more. So, let me first talk about we know that the standard forms of parabola we saw is of the form y square equal to 4 a x or y square is minus 4 a x or x square is 4 a y or x square is minus 4 a y. So, these are given by this is the parabola y square equal to 4 a x. This has vertex at the origin, all these parabola has vertex at the origin, and then we have this is the parabola x square equal to 4 a y, and then we have this parabola. If I reflect in the y axis, I get y square equal to minus 4 a x, and this is x square equal to minus 4 a y. Now, let us look at a parabola of this type x square equal to 4 a y or x square equal to minus 4 a y. So, here you see that y is given by x square by 4 a or x square by minus 4 a. Right. So, this is a special type of quadratic equation in x, y is given as a quadratic in x. So, this gives y equal to 1 by 4 a x or x square, or y is minus 1 by 4 a x square. Now, if we consider general quadratic polynomial in x, so consider the general quadratic y equal to a x square plus b x plus c, where a is given to be non-zero. Now, we will show that this again represents a parabola, not in the standard form, the vertices need not be at the origin, but how to find the vertices of this parabola. So, we can write this as y is a times x square plus b by a x plus c by a, and then what we do is we complete square here. So, we can write this as x plus b by 2 a whole square. So, this will give you x square plus b by a x plus b square by 4 a square. So, we subtract b square by 4 a square plus c by a, which is same thing as a times x plus b by 2 a whole square minus this b square by 4 a square multiplied by a gives b square by 4 a plus c by a times a gives c. So, this is y is equal to a times x plus b by 2a whole square minus b square minus 4 a c by 2 by 4 a. Or this can be written as y plus b square minus 4 a c by 4 a is equal to a times x plus b by 2 a squared. So, this is of the form y minus k is equal to a times x minus h squared, where k is negative of this. So, 4 a c minus b square by 4 a and h is minus b by 2 a. So, this is of the form y equal to, if I put y minus k as y dash, then we have y dash equal to a times x dash square. So, if we draw the graph of this parabola, you see the vertex is shifted to h comma k. So, if my suppose a is positive, then this parabola will be opening up and the vertex is at point h comma k, which can be anywhere. Here we are taking in the fourth quadrant, and then the parabola will be like this, right. So, this is the vertex, and here the axis of the parabola will be this line x equal to h. The parabola is symmetric about this line, and the focus will lie on this axis, and in this case the directrix will be a line some y equal to L. So, it is not difficult to find the focus and directrix also. We know that the parabola is given by all set of all points whose distance from the focus and directrix is same. So, since we have this vertex, here is h comma k, this distance from the vertex to the directrix, this is L minus k, and the distance of focus to this, if my focus is say at the point h comma alpha, then the distance from focus to vertex this is alpha minus k. So, because the parabola, the vertex is equidistant from focus and the directrix, we have alpha minus k is equal to L minus k, which means alpha minus k, this should be mod of L minus k. So, this is k minus L. So, alpha plus L is equal to 2 k. This is one equation we get. And if you take any other point on the parabola, let us say we take the point P, which is some x comma y is alpha, then we have the equation of parabola is y minus k is a times x minus h square. So, putting this x comma alpha here, we have alpha minus k is equal to a times x minus h square, which will give x minus h square is equal to alpha minus k by a, or x is equal to h plus minus square root of alpha minus k by a. So, P point is, if we take this point P, this has coordinate h plus square root of alpha minus k by a comma alpha. Now, what is the distance of P to F? Distance of P to the focus is equal to this difference in the x coordinate. So, this will be square root of alpha minus k by a, and what is the distance of P to the directrix? P to the line L, this distance is, the y coordinate here is alpha, and this is y equal to L. So, alpha minus L, because we are taking here this y equal to L. So, alpha minus L. Now, P f equal to P L will imply alpha minus k by a is equal to alpha minus L square, and from these two equations we can solve for alpha and L. So, let us put this is equation 1. 1 implies k is equal to, sorry, let us put from 1, let us write L in terms of alpha, 2 k minus alpha, and then putting this in this equation 2, alpha minus k by a equal to alpha minus 2 k minus alpha square, which means alpha minus k is a times, this is 2 alpha minus 2 k. So, 4 alpha minus k squared. This implies alpha minus k is equal to 1 by 4 a, since alpha is different from k. Right. So, you see h comma a is here, the focus is different from the vertex. So, this is, since alpha minus k is non-zero. So, we cancel alpha minus k, I get alpha minus k equal to 1 by 4 a, which implies alpha is equal to k plus 1 by 4 a, and if you use this, this will give L is equal to 2 k minus alpha, which is k minus 1 by 4 a. So, for the parabola, y minus k equal to a times x minus h squared, the vertex is at h comma k, focus is at focus was at h comma alpha, which is equal to h comma alpha we got as k plus 1 by 4 a, and directrix is the line y equal to L, that is y equal to k minus 1 by 4 a. So, to remember this, if we have this vertex is h comma k, that means that this distance is minus k. So, this directrix is at distance 1 by 4 a from this vertex, and the focus is again at distance 1 by 4 a. We know that the vertex is the midpoint between this focus and this point on the directrix. So, the distance between focus and the directrix in this case is 2 a, 1 by 2 a. Okay, so, we have seen that we have defined parabola by using focus and directrix. So, parabola is set of all points such that the distance of any point to the focus is equal to the distance of the point, perpendicular distance of the point from the directrix. Whereas, we have defined the ellipse and hyperbola in terms of two fixed points called the foci, and then we defined. So, let us look at ellipse and hyperbola. In terms of focus and directrix. So, let f be any fixed point let us take on the x axis. So, f is any f comma 0 and suppose we take let us take ellipse. So, we have f comma 0 or we write this as c comma 0 and minus c comma 0 and then ellipse with major axis on the x axis is given by this. This is a comma 0 minus a 0, this is 0 b 0 minus b. So, if we look at this ellipse, x square by a square plus y square by b square equal to 1, where a is greater than b and c square is a square minus b square in this case. Now, let us look at this line. So, consider the line x equal to a square by c. So, where is this line? This is some line x equal to a square by c. Note that since a is greater than c, this will be greater than a, since a by c is strictly greater than 1. So, this x equal to a square by c lies on the right of this ellipse. Now, if we take any point p x y on the ellipse, let us look at the distance p f 1 and the distance to this line p l. So, distance of p x y on the ellipse to f 1, which is c 0, is p f 1 equal to square root of x minus c square plus y square. So, p f 1 square is x minus c square plus y square, which is equal to x square minus 2 c x plus c square plus y square. But what is y square? Y square is equal to b square times 1 minus x square by a square. So, let us put this. So, this gives x square minus two c x plus c square plus y square is b square times 1 minus x square by a square. So, this gives 1 minus b square by a square x square minus 2 c x plus c square plus b square. But what is this? This is equal to a square minus b square by a square x square minus 2 c x plus c square plus b square is equal to a square. C square is given by a square minus b square. Again let us put a square minus b square as c square here. So, this is c square by a square x square minus 2 c x plus a square. So, this is same thing as c by a x minus a whole square, right, because if you square this you get this term plus a square minus 2 times this will give 2 c x. Here let us put c square by a square outside, then we get x minus a square by c whole square. But what is the distance of P to L? But if you see this point is P x y, this is L, the distance from P to L is x minus a square by c, mod of this distance is mod of x minus a square by c. So, therefore, this x minus a square by c square is P L square. So, thus we get P f 1 square is equal to c by a square times P L 1 square, that is P f 1 is c by a times P L 1. And recall that we defined the eccentricity of the ellipse to be c by a. So, this is E times P L 1 P L. So, thus P f 1 by P L is equal to E. So, the ratio of any point on the ellipse to the distance to this line x square this ellipse and the line x equal to a square by c P f 1 by P L is equal to equal to the constant E. Similarly, if we take this line x equal to minus a square by c, similarly for the line x equal to minus a square by c, the ratio is equal to E. So, thus these lines x equal to plus minus a square by c are called the directrices of the ellipse x square by a square plus y square by b square equal to 1 with a greater than b. We can do conversely, and now we can define ellipse or also hyperbola using directrix. So, let us take a conic section. You will see that we will get parabola, ellipse, hyperbola using this conic section. Having a vertex at the origin, focus on the x axis and directrix a line parallel to the y axis. So, we have x axis and y axis. We take a vertex v 0 0. Let us take focus to be this point with coordinate f comma 0, and let us take a line L What is the equation of this line? This line is x equal to some alpha. Now, let us look at let us find the locus of points P such that the ratio P f divided by P L, where this is the perpendicular of any point. So, if we take any P x y, we look at P f distance and this perpendicular distance P L. This is equal to some constant E. This is a constant. Then, because we have V, since V 0 0 lies on the curve, we have V f divided by V L. This should be equal to E. This implies V L distance is V f by E. V f is equal to f here. So, this is equal to f by E. So, therefore, the line L is x equal to minus f by e. So, let us draw this again. And we have this line x equal to minus f by e. Now, take any general point p x y on the curve, then p f square is equal to e square p l square. What is p f square? P f square is x minus f whole squared plus y square. This is equal to e square times p to l, this length is x plus f by e. So, x plus f by e squared. So, if we simplify this, this gives x square minus 2 f x plus f square plus y square equal to, this is E x plus f squared, which is E square x square plus 2 E f x plus f square. So, f square cancels and this gives 1 minus E square x square minus 2 f 1 plus E x plus y square equal to 0. So, let us put p is equal to f times 1 plus e, we get 1 minus e square x square minus 2 p x plus y square equal to 0. Now, if we look at this equation, this is the equation such that the ratio of the distance of p to f and p to the line L is a constant E. Now, if E is equal to 1, we get, and the first term is not there, we get y square equal to 2 p x, which is a parabola. So, this we already saw before, that if we take the ratio to be equal to 1, then we get a parabola. What happens if E is less than 1? If E is less than 1, then 1 minus E square, this is the positive. So, we get some a square x square minus 2 p x plus y square equal to 0. So, this we can write as x square minus 2 p by a square x plus y square by a square equal to 0, or x minus p by a whole square, p by a square square plus p square by a to the 4 plus y square by a square, sorry, this will be minus, equal to 0, or x minus p by a square plus y square by a square equal to p square by a to the 4, which is equation of an ellipse. Though it is not in the standard form, but here the ellipse, you see if you put y equal to 0, then you get x minus p by a square is p square by a square. So, x is equal to the center of the ellipse is at the point p by a square and 0, and we get an ellipse like this. In this special case, E equal to 0, if you see this was the general equation, if I put E equal to 0 gives x square minus 2 p x plus y square equal to 0, which is equation of a circle. So, in ellipse we see if we put E equal to 0, we get equation of a circle, and if E is greater than 1, then we can write the equation as this equation. If E is greater than 1, this is negative. So, we will write E square minus 1 x square plus 2 p x minus y square equal to 0, and this here is positive. So, this is an equation of a hyperbola. So, one can define this ellipse and hyperbola also using focus and directrix, right. So, all these conic sections, parabola, ellipse and hyperbola can be defined as the locus of all points, such that the ratio of the distance of the point to a fixed point called focus and a fixed line is a constant E, which is the eccentricity. Okay. So, next, just like we did for ellipse, we found the equation of the directrices. Similarly, for hyperbola there will be two directrix, and the equation of the directrix we can find. So, consider the hyperbola x square by a square minus y square by b square equal to 1. So, here the vertices are a comma 0 and minus a 0. And focus f 1 is c comma 0, there is another focus here f 2, minus C 0. Now, again let us look at the line x equal to a square by c. In the case of hyperbola, we know that c square is equal to a square plus b square. So, therefore, this is greater than a square. So, a by c is less than 1. So, therefore, a square by c, this is strictly less than a. So, this line here is x equal to a square by c. Now, if I take any point p x y, let us calculate what is the distance p f 1 and this distance p l. So, p f 1 square is equal to x minus c square plus y square, which is equal to x square minus 2 c x plus c square plus y square, but y square equal to b square times x square by a square minus 1. This is b square by a square x square minus b square. So, therefore, p f 1 square is x square minus 2 c x plus c square plus b square by a square x square minus b square. So, this is equal to 1 plus b square by a square x square minus 2 c x plus c square minus b square, but a square plus b square is c square. So, this is c square by a square x square minus 2 c x plus c square minus b square is a square. So, this can be written as c by a x minus a whole square, which again I can put c by a out. So, c by a square times x minus a square by c whole square. Since c by a is eccentricity E, this is E square times P L square. So, therefore, P f 1 by P L is equal to E, which is greater than 1 in the case of hyperbola. So, the line x equal to plus minus a square by c are the directrices of the hyperbola x square by a square minus y square by b square equal to 1. If we take the hyperbola with foci on the y axis, if we take y square by a square minus x square by b square equal to 1, then the directrices will be line y equal to plus minus a square by c. So, again just like ellipse, we get equation of the directrices given by x equal to a square by c and x equal to minus a square by c in this standard form. So, this shows that all the conic sections, parabola, ellipse and hyperbola can be described in terms of focus and ellipse, focus and directrix, and the definition is that the ratio of the distance to a fixed point focus and the perpendicular distance to a line called directrix should be a constant, and depending on whether the constant is equal to 1, less than 1 or greater than 1, we get parabola, ellipse and hyperbola. So, we will stop here today, and in the next class we will learn about tangents and normals of parabola, ellipse and hyperbola, etc. Thank you.